Hello, all. It is late on Sunday night, and I am doing a chemistry lecture. And I'm looking at my video and not the camera, so it's going to look like I'm not looking in the right place. Us old people. Okay, so I'm not sure how this is going to go, but we shall see. I'll get better as time goes on, since I'll have a few videos to make here. We're going to start out with talking about Module 3. So I'm going to make a video. I've got my notes in front of me. I'm just talking about Module 3, and I've got my trusty whiteboard, and we're going to do some videos also on working problems. There's a lot of math. There's a lot of math in this module. We're going to do it in two different videos because it's just too much to do. So I was taking my notes. It's way too much to do in one video, in one night, or just in one session. Not that you're doing your work at night. So let's talk about atomic structure. We talked about before that early scientists finally came to understand that the possibility that things might actually be made of atoms or something smaller that we couldn't see. And if you begin reading, there's lots of history and lots of theory and lots of good stuff like that in this chapter. And I encourage you to read it because it does help things to make sense, help to make the progression of what they learn make sense. And I think it's a little bit easier to learn if you learn it with some context of history. Otherwise, you're just trying to memorize, like, I don't know, what was Thomson's theory? What was Rutherford's theory? What was Bohr's theory? Like, it just, then you're just kind of memorizing more random things. So try to think of it as a progression. And so Crookes, there was a William Crookes, a scientist, and he was learning how gases behaved when they were exposed to electricity. So electricity would heat something up. So he was putting electricity through these different gases, and he would see that they would glow. And they were called those cathode rays. It had to do with the battery, the way he was sending electricity, and that the rays were coming from. So now that's called the cathode ray tube. And he continued to do his experimenting, and this began to develop the understanding of an electrical charge. And I was really glad to read in the book when they say that even scientists don't fully understand electricity. They understand how to describe it, how electrical charges behave, how to generate electricity, but as far as like what it is, what it came from, what electrical charges actually are, they don't fully understand. That really made me feel better because I sometimes think, as much as I've studied electricity in different capacities, I still feel like it's this kind of unknown magical thing. For you Harry Potter fans, it's like apparating. I don't know, it feels as magical as something like that. It seems like an unknown thing, but we can describe it, we can quantify it, even if we don't fully understand where it came from or exactly. We can understand its nature, though. So as you read through, there's lots of good stuff as you read through the beginning of this chapter, and read about Crookes and the cathode ray tubes. It really is interesting because he could use a magnet and sort of change the way the light moves, so he could tell that there was positive and negative charges going on. And so then they give a whole section talking about electrical charge. I want you to read that. I truly want you to read it, but I want you to come away with it knowing some basic things. I want to make sure that you know that like charges, so a positive and a positive together, repel each other, and that opposite charges, yes. What do you need? I'm just recording, but it's okay. Do you need anything? Okay. And then I want you to make sure you know that opposite charges attract each other. So when you have a positive and a negative charge, those are going to want to come together. But like charges are going to, like magnets. So and I'm sure you guys probably know this. You've probably studied, hopefully, some magnets or electricity, encountered that. So those things should hopefully make sense too. And also come away with that from that section knowing that every substance on Earth has an electrical charge. Sometimes it's neutral. Sometimes there's enough positive charges meeting the amount of negative charges, and it's just neutral. But if the positive outweighs the negative, you have an overall positive charge. And if the negative outweighs the positive, you have an overall negative charge. It's just like adding positive and negative numbers. If you add up with a negative number, you have a negative charge, that sort of thing. So this knowledge began to lead to the discovery of electrons having a negative charge and protons having a positive charge. And later they learned about neutrons, but they didn't quite know about those yet. So atoms of an element are differentiated by the number of protons, neutrons, and electrons they have. And so there's a way to determine how many there are. So if you look at, to do with my periodic table, your periodic table, talked about there's lots of good information on there. You're going to learn about the atomic number of different elements. If you look at your periodic table, hydrogen has an atomic number of 1. Helium has an atomic number of 2. Lithium has an atomic number of 3. Beryllium is 4. Boron is 5. Carbon is 6. It's that little number right above it. So it's the top number as you look at your charts. So you can see that 1 and that 3 above lithium, the 4 above beryllium there. Okay? Atomic number. That is one important thing that you're learning from periodic table. So you don't have to memorize those. They're all on there. And you can use this on a test. So atomic number is going to tell us the number of protons. So hydrogen has 1 proton. Helium has 2 protons. You're going to have the same number of protons in an atom as your electrons. So that's easy, right? So far it's easy. Not everything in this chapter is hard. There's just like a ton of information. So we're starting out pretty simple here. So atomic number tells us number of protons, and then there's going to be an equal number of protons and electrons. Scroll through my notes here. Now we have, sorry, my microphone was like, I can hear myself talking. Hopefully it's recording. It would be really annoying to record all this and find out that it was impossible to hear. Maybe it's because of my chart. It's like making the sound echo on the microphone. I don't know. Okay, so then determining the number of neutrons in an atom. So sorry, it's super distracting, the feedback. I'm going to actually pause this. I can upload this in more than one video, but I want to listen to it, make sure that it's not sounding terrible before I continue to record an hour's worth of video.